The universe is complex. So scientists, in order to understand the universe, develop models about the universe, which are a simplification of the universe. So these models could be models of reality, but another further simplification is to use causal models. And causal models use variables. Variables is a simplification of things that happen in the universe or things that are in the universe into a more manageable and measurable thing. Variables can be found in causal models, but can also be found in probability models. But there is a difference in what is considered a variable in causal models and in probability models. So causal models are the models that are used in science and research. And in this case, a variable is considered a characteristic or attribute of things. Those things could be persons, animals, places, events, objects that may take more than one value. This is an important distinction. We have variables and values within those variables. In probability models, we talk about random variables. And random variables are expressions whose value is the outcome of an experiment. But in this case, experiment is not a scientific experiment, but it is an experiment of a random process. For example, tossing a coin or rolling a dice. We are going to focus on the variables that we use in science and research. So let's consider that the thing in this case is humans. So variables would be attributes or characteristics of humans. Let's start with one example, species. Is that a variable? Well, this is a tricky one because we said that variables can take more than one value. And if the thing that we are interested in is humans, species is not a variable because it can only take the value human. So in this sense, it's not a variable. But sometimes it's useful to have this type of variables that only take one value in this case, but it could take more than one value in another context. For example, if we are considering animals or organisms, then species would be a variable because it can take several values. Humans, dolphins, whales, dogs, etc. Gender is another variable, and here are numerous examples: age, nationality, language, hair color, height, weight, number of legs, type of shoes, intelligence, education level, psychological state, and personality. Okay, so here are cases of variables and values. So gender is the variable, and it can take a number of values: female, male, or other genders. Age is a variable that can take different values, and age could be different types of variables. Like, for example, could be the values that can take could be in integers. So we say 0 years old, 1 year old. But if it is in we consider months, then we can say 1 point something years old. Country of birth is a variable that can take a number of values: Australia, New Zealand, UK, USA, etc. Language is a variable that can take a number of values: English, Spanish, Arabic, and others. Hair color, black, brown, blonde, etc. Height takes values from, let's say here, 0 to 2 meters. Intelligence, another variable. I give you here 2 examples. We can measure it as low, medium, and high, or 0 to 200 IQ points. Education level, primary, secondary, university. So these are cases of variables with values that can take that variable. There are different types of variables. The main distinction between variables is whether the variable is categorical or numerical. If the variable is numerical, then the values will be numbers. If the variable is categorical, then the values will be categories. So in the case of categorical variables, we have the regular categorical, which are also called nominal, and in this case, the values would be names. So, for example, we saw in the previous slide the nationality as a variable. The values of that variable are names: Argentina, Cameroon, Scotland, Australia, etc. No numbers. Another case of categorical variable is the ordinal. So ordinal gives an idea of order. For example, when we measure intelligence as high, medium, low, that is an ordinal variable. We know that high is more than medium and medium is more than low, but we are not using numbers. In a way, we can say how much more is high than medium, how much more is medium than low. We can't. We just have an idea of order, but we don't have an idea of the distance or the interval between those values. Okay, so let's go to numerical variables. There are two ways of classifying numerical variables. Discrete and continuous is one classification. Discrete are when we have a specific number of values that this variable can take. For example, if the variable is number of correct answers in a test, and that test has 10 questions, then the values that this variable can take are 11. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So these are 11 discrete values that numerical variable can take. Continuous, there are infinite number of values. Let's say distance run in my morning run. Well, could be 1,522.223 meters, 2,398.112 meters, etc. So there are infinite number of values that variable can take. These are continuous variables. Sometimes the other classification, interval and ratio, are conflated with discrete and continuous, like it's considered that interval are discrete and ratio are continuous, but that's actually not correct. Ratio variables are variables that have what is called an absolute zero, and interval variables are numerical, but they don't have an absolute zero. What's an absolute zero? An absolute zero is that when a variable takes the value 0, that means that there is an absence of what we are measuring with that variable. But in other cases, we have 0, and that is not absence of what we are measuring. For example, if we measure temperature in Celsius, then the 0, that's not absence of temperature, because we can go lower than that. But in some cases, like for example, the variable number of questions answered correctly, that's a ratio variable, because the 0 is absence of number of correct answers in that test. So that's a discrete and ratio. Typically, the continuous variables like distance run could be a ratio, but that's not always the case. Now, why are they called ratio? Well, because when there is absolute 0, it makes sense to do ratios or divisions between values of that variable. But when you have an interval, you can do sum and addition, but you cannot do ratios, or it doesn't make sense to do it.